Let's take a look at question 19.50. We're starting with this aldehyde and we're treating it with this Wittig reagent. But keep in mind that this is a stabilized Wittig reagent, right? Because we have the phenyl ring up here, which could stabilize the negative charge if we were to draw it here, right? So what I'm saying is, if you were to draw the Wittig reagent as the ylide instead of the ylene, so that we show our carbanion like this, we have our 3 phenyl groups attached to our phosphorus. We have our carbanion like that. But since we have our aromatic ring here, we could draw resonance arrows to show the stabilization of that Wittig reagent. So since it's a stabilized Wittig reagent, we should end up with an alkene that has an E configuration. So we should end up with an E alkene. So let's draw what the structure of that alkene would look like. Let me just delete this. And so where do we start? We're going to end up with all this part of the molecule. So let's draw that out carefully. We have our hydrogen here. We have our double bond. And our double bond, where it's going to pick up is right here. We're going to have the double bond to this carbon, to the hydrogen, and to the phenyl. But remember, we're ending up with the E product. So the phenyl should be on the opposite side of the tert-butyl. So we should put the phenyl like this, and then we can put the other hydrogen over here like that. In 19.50b, we're dealing with a non-stabilized Wittig because we just have an ethyl group on here. And when we have unstabilized Wittigs, we should end up with the Z product, should be our major product. So again, we're going to start by drawing all this part of the molecule. So let's draw that carefully. We have our phenyl, then we have our double bond, we have another phenyl here. And we're going to have our ethyl group on the same side as all this group over here so that we end up with a Z alkene. You can see the 2 hydrogens are on the same side like that. And thus you can see that when you have a stabilized Wittig reagent, you end up with an E alkene. And when you have a Wittig that is not stabilized, you end up with the Z alkene. Question 19.50.